Hey, Mathis, you're a regular here.
Hey, I found another excuse to come here.
Yeah, let's do the round of applause and kick it off.
All right. Right, so let's talk about Dustmite. First of all, the talk for this is a Markdown file. After the talk, I'm going to share a link for it in chat. So Dustmite is a tool that ships with a DMD distribution. So if you have DMD on your computer, you already have Dustmite. It's written by Cybershadow, who should very much be proud of it because it is immensely useful if you're doing bug reports. Basically, this is a reducer. And what a reducer is a thing that takes your gigantic program that just unfathomably hit a DMD bug, which of course never happens, but just in case, and turns it into a very small, very tight, very adorable, very readable error that you still don't understand. So how does this work? A reducer is basically a program that takes two things. It has a test folder and it has a reproduction script, called a tester in this case. What the tester does is it demonstrates the presence of the bug, or it tests for the presence of the bug. In other words, the tester can be anything. It can be an executable, it can be a D program, it can be a bash script, a bat file if you're a Windows using weirdo, who I'm not going to be focusing on in this talk. So if some of the shell commands that I give don't make any sense, just ask an AI to translate it into PowerShell for you. They're really good at that. Then just run it blindly, don't worry, it's going to be fine. Dustmite will actually tell you if you've made a mistake in the repro script, so that should be good. I'm just going to walk you through the basic steps of how to use this. You have some project, and the project has developed an issue. So what you want to do is you make a separate clean folder for your reproduction run. Then you copy your entire project into that folder and you call that project 1 or source 1 or something ending in 1. Then, this is actually important, in the repro folder, you make your reproduction script, which I'm going to call repro1.shell or .bat, whatever. This is going to be run from within the project folder, but it must be placed outside the reproduction folder. I'm going to explain that in a moment. It has to be executable. Now you can run Dustmite. Dustmite has a very simple syntax. It's Dustmite, source folder, repro folder. This will probably fail. This says it's going to create a source folder.reduce. That's not true. It's going to give you an error. The error is probably going to be that you left some binaries in there. Dustmite doesn't like binaries because it has to keep everything in memory. So you have two options at this point. You can either clean up your binaries and just do a pure source run, or you can do what everybody does and just pass the force parameter and say, yeah, okay, you're going to have some difficulty with this. I don't care. I have 32 gigabytes of RAM. Go for it. So that's going to be fine. Dustmite is going to run, and it's going to run for a very long time. DMD is not exactly a super fast compiler, especially if you're using templates, and it's going to have to do like 10,000, 100,000 DMD runs. So at this point, you want to take a coffee break and then take another coffee break and then go home for an extended weekend. You're getting this folder out source 1 reduced. I want you to not even look at that folder. I want you to immediately take this folder and make a copy of it called source 2. There's a reason for that. That source 1 reduced folder is holy. You have to keep it holy, like the Sabbath. Because also like the Sabbath, it may have taken you 7 days to get there. Don't touch it, don't even look at it, don't make any changes. There's a reason for that. And I will get to it in a second. But just to summarize, we're ending up with this folder structure. It is very easy to say, like, okay, I'm just going to take a look at the reduced folder. I'm just going to see what the actual issue was. Oh, I understand it now. I understand perfectly what the compiler is. No, you don't. I'm going to just make some fixes here. They're not going to break anything. They're just going to make the actual issue easier to see. No, they're not. They're going to make the actual issue disappear. And then you've already clicked save, and you've already closed your editor, and now 7 days of work is down the drain. Make a copy. So that's actually it. That's how Dustmite work. You can now go home now. We can do a very deserved point. Okay, no, there's a bunch of more details. To understand how to get the most use out of Dustmite, it's important to have a model for what Dustmite actually does internally. So from Dustmite's perspective, what it does is it gets given this folder. What it does is it reads it into a tree internally. Every subfolder becomes a tree element, then every source file becomes a tree element, and then inside of that, every D construct becomes a D element. Every function becomes a tree element. Every statement in that function, every parameter, every node of an arithmetic expression, and all of that gets read into this giant tree that's just in memory. And now Dustmite tries to do, in a loop, again, this. It does a reduction operation. Like it takes one element from this tree, like one file, and it's like, okay, maybe I can delete this. Maybe I can just drop it from the tree. I make a new tree with that element removed. I write it out into a test folder. And then I run the reproduction script against that test folder. And the reproduction script is going to tell me if the bug is still present. And if yes, I'm just going to say, okay, great. I'm going to look around that area in the tree a bit more. If maybe I can remove the next file, and the next file, and the next file. It keeps going like that. And once it can't find anything more in that area, it tries to recurse. It tries to go deeper. Maybe I can remove this leaf of an arithmetic tree. Maybe I can remove this parameter entirely. Maybe I can remove this function parameter. Maybe I can remove this template parameter. And 90% of the time, it's just going to immediately fail. 10% of the time, it's going to keep digging. It's going to keep digging deeper and deeper until it gets stumped by something and really can't continue. And once it can't continue, it just starts over from the start. And does that in a loop repeatedly, exactly until it gets a full pass through the entire tree without being able to remove anything. And then it writes out the reduced file and exits. The quality of the reproduction you get out is determined by the quality of your reproduction script. And there are a lot of issues you're running into here. The first and the easiest issue to run into is, I'm just going to give it the source file and then I'm going to give it my binary, or like the DMD command. That's sort of the instinct everyone's probably going to go for, and then they're going to be like, I don't understand how Dustmite works. The key is that Dustmite treats the reproduction script exactly the opposite way around from the way you would think about it. If the reproduction script exits with a success, then there's a bug. If the reproduction script exits with an error, then we have lost the bug. So that's kind of counterintuitive, but it lets you do some cool things. For instance, if you're trying to debug a crash in DMD itself, what you're ending up is a script like this. So you just run the compiler, and if the compiler exits with an error, that's going to kick the script. Actually, no, it doesn't kick the script in this case because we didn't say it exit on error. It's just going to keep going. But then it's going to do this test, which is the exit code of the previous command 139, which is the Linux error code for a seg fault. And if it is, then we get a successful exit because that's the last line in the script. And if it isn't, we get an error exit. The key is, for instance, compiler errors count as an erroneous exit, and so paradoxically don't confirm the presence of the bug. Like if Dustmite has inserted a syntax error, the bug has gone away. We are no longer seg faulting. So we get an error exit. We get a successful exit only in the presence of a seg fault. This way, you're going to keep effectively Dustmite on target. Otherwise, if you're looking for an error, then it's very easy for Dustmite to create an error, which is, of course, not the same error that you went in with. And then it's going to reduce everything to that meaningless error. And actually, I've been in situations where I've been filtering for a seg fault, and at the end of the reproduction run, I got another seg fault. Which was somewhat surprising, though it really shouldn't have been. You can do the same thing if you go one step further. If your program has a crash with DMD, you run DMD with program output, and again, if DMD gets an error, it just aborts the repro script. And then you run your program. No, actually, in this case, it doesn't. In this case, this actually has a very subtle trap in it, now that I'm looking at it. I'm wondering if someone can tell me what it is. Any takers? Now, once again, what is killing us here is that bash does not exit on error. So if you left the binary for test in your folder, what's going to happen is Dustmite is going to reduce the code in a way where it introduces an error, and then the DMD run is going to fail, but the script isn't going to exit, and it's just going to run the old binary. So you have to be a bit careful there. But what that is actually going to do in Dustmite is going to get rid of all the source code, and it's going to be like, all right, I've reduced this bug to one binary, which is not entirely what we wanted. So usually what you would do is you would explicitly test after this DMD run, DMD test, OF test, or exit 1, actually. Yeah, and then it would work, right. That's the sort of thing you do run into a bunch, but most of the time what happens then is Dustmite gets rid of your source very quickly and you don't waste much time. Right, but these are all still kind of bad repros, because usually we have more information than that, and usually we don't want to just replace a seg fault with another seg fault. For instance, if you can rewrite your program, if you already know where the seg fault is, you just don't know why. You can rewrite your program so that, for instance, it does an assert for the seg fault just before the point where it happens. And now you have an error message. Now you have a specific file and line number. Now you can really drill down. Now you can, for instance, say, I'm going to run my program. If it's successful, I'm going to kick out the reproduction script with exit. I'm going to grab the standard error, and then I'm going to check for the actual error message that I put in. That's starting to be good. Like now, Dustmite runs out of places to go astray. You can do that with DMD error messages as well. Even if they have formatting in it, you just run them through cat, and then you see the exact thing. You can just copy paste it in the file, in the repro file, and you can test for a specific DMD error at a specific file and line location. There's a problem then, which is that if you're doing that to test for a null, then what Dustmite is going to do is it's going to see the assignment to that variable in the first place, and it's going to be like, yeah, I can optimize that out. That preserves our issue, because then it's still null, and it still would produce a seg fault. Dustmite is not very understanding of the thing that you're specifically looking for. You do have to be careful. One of the ways you can work around that is you can just take the one file where you're actually testing for the bug and just move it outside of your repro folder. And then just import it with i. The repro folder isn't like, the script isn't contained to it. It's just a Dustmite mechanic. So you can just move your file out of that, and then Dustmite isn't going to touch it. It's just going to touch everything else. Actually, if you think about it, that is exactly the reason why it was so vital to keep the repro script outside of your source folder. Because otherwise, Dustmite is going to be like, I'm looking for a successful exit of this repo script. And it turns out bash scripts are successful if you delete everything that's in them. And then you have a very, very short production run that ends with not very much in your reduced folder. At this point, an important safety warning if you're on Linux. DMD can get into infinite loops. DMD can get into very funny crashes where it just sits there and it eats up memory. And the first thing you start noticing that you have an issue is that your mouse starts moving sort of slowly. At which point it rapidly becomes too late to do anything about it. And when this happens at 3 a.m. when you've already gone home for the night, it's a bit uncomfortable the next day, partially because you have no idea what happened. The first thing you want to do is just set new limit. You just want to run DMD, look at your memory usage, and then say, okay, this took like 8 seconds. I'm going to limit it to 15 seconds. Be a bit safe. I'm going to limit the memory usage to 4 gigabytes. That's not going to be enough. Limit the memory usage to 8 gigabytes, 16 gigabytes, whatever, as long as it's less than your free RAM. You can do that with timeout under Windows. I am being told by an AI. I'm also being told there's no replacement for the memory limit thing, so good luck. Maybe use WSL for that. There's some more things you can do to improve things in the source folder. First of all, you can just run dub in your repro script. You can just run reggae in your repro script. You can run make, whatever. I recommend going down to DMD. The reason I recommend that is because it puts the minimal distance between you and the actual command that leads to the error. And usually, as you're going through, you're at like source 2, source 3, source 4, you're at repro 3, repro 4, you want to make some adjustments. You want to maybe drop a bunch of files from the DMD run and just focus on the ones that actually cause the error if you run them. And that is all a lot easier if you just have the DMD command line in your repro script. Being a bit careful, but you should absolutely clean up all the build binaries. This is specific, that come from resources that are in your repro folder. As I mentioned earlier, you can run into issues where a build step fails and it just uses the binary that's already in there. Dustmite, again, can clear these out for you by noticing that they're being rebuilt anyway. But why take the odds? The first time you start Dustmite, you should already be pretty confident that it's going to get to a satisfying conclusion. And one of the ways you can do that is by rebuilding every binary that is in your folder with manual DMD steps. You can run dub.-v to see the actual DMD calls that it makes and just copy-paste those in. Then you have a situation where all the binaries that you want to test are created during the repro run, and that's the way it should be. An important side note, the source code that is being reduced does not have to be D. Like we noticed earlier, it will absolutely replace the repro script with an empty file, but you can do it with everything. For instance, if you're importing like a list of modules with J, as is commonly done for unit tests, you can tell it that's a TXT file or whatever. We treat TXT files as split at line endings or as split at spaces. And then Dustmite will absolutely take that file and be like, this is not a D file, but I know how to reduce this. I can take one line out here, one line out there, and see if it still works. So you can provide that multiple times as a parameter, and you can absolutely reduce anything. Like I'm being told people have reduced C++ with this. It's not D-specific, it just has D advantages. So right, you're in the middle of your first run. Right, this we've already done. Kind of skipped ahead a little. So we have source 1 reduced. And you've copied this to source 2. And you've looked at it, and it looks pretty small, but you wouldn't call it minimal. Like this is still 200 lines of D. This is still 1,000 lines of D. You're not happy with it. At this point, you're going to have to help Dustmite a bit, because there are steps that Dustmite isn't good at. One of them, for instance, is mutual dependencies. Like you have one function, and it's calling another function with a parameter, and that one is calling the first function again with the same parameter. The reason this doesn't work is that Dustmite always does single steps. Dustmite tries to take out the parameter in the foo call. Now it gets the syntax errors. Repro doesn't work anymore. It tries to take out the parameter in the bar call. Syntax error. Repro doesn't work anymore, semantics error, whatever. Repro doesn't work anymore, and now it's stuck. It can't get rid of them because it can't remove one without the other. But like as a human, looking at source 5 and not source 4.reduced, just to emphasize that again, it will be tempting. Looking at source 5, you can now be smart about it, and you can be like, okay, I have a clean folder here, I can experiment. I can just take these parameters out entirely, or I can just replace them with an int parameter that takes 0. I can make this a lot easier. Another one is that if you have a template instantiation, There are several clever things you can do. One of them is that you can, for instance, say, okay, this type doesn't actually seem to matter. I'm going to turn it into an int and see if the error still occurs. I'm just going to take away everything that's specific about my code and see if you still get the error. This is sort of, in university, like we were taught that there are formulas for differentiation, and for integration there's one that is called the method of looking real close. And this is very much something that Dustmite profits in this case. So, however, the first thing you have to do is you have to look at the reduced source code, maybe rerun your repro command, and absolutely double check that the bug that you have now is the bug that you started out at, because that is not in any way, shape, or form guaranteed. So you just want to be sure of that. All right, now you say your reproduction is good, but you want to go further. So the first thing you can do is like inline libraries. Very often you're now in a situation where there's a crash, even a DMD crash, and the first thing you see on your end is that there's a Phobos instantiation, like typecons nullable, for instance, or we have a parameter that takes this time. And now you can probably file a bug against Phobos, but it's probably not going to be Phobos' fault, because no source code should be able to cause a compiler crash. If you're in safe code, no invocation of Phobos should be able to cause a runtime crash either. So now this is still DMD's fault. It's just somewhere in source code that we can't see. The next thing we can do is we can just take that source code and just copy it into a repro folder. If you're looking at dub, I don't know where it is on Windows. I have not even looked it up, I'm sorry. But on Linux, this is in your home folder in .dub packages name version repo. This changes a bit. You may have to look around there. The version should always be correct. The Phobos sources are in your DMD distribution. They're next to the compiler in the source folder. So if you're importing standard typecons and you're seeing a problem with standard typecons, you just grab a copy of typecons.d, move it in your project, rename it, and this is actually important. You have to rename it. The reason why you have to rename it is because of the standard trap, which is to say, from Dustmite's perspective, it takes an input like standard typecons, and it's like, I can remove the typecons. The typecons part doesn't matter. I just have import standard, and it's just a bug in it, which is great from the Dustmite's perspective. It's not great from our perspective, because now a reproduction run that took like 1 second or like 300 milliseconds per invocation, for instance, of standard math, now takes like 1.2 seconds because it has to pull in standard regex and standard UTF, big UTF table or whatever they have these days. And so actually you can do that in a shell script. I didn't have that in here yet because I forgot. But you can actually do an inverse grep, like grep-v, import standard any number of spaces semicolon. And this is a very common pattern. You can actually just exclude it outright. You can just, if you see that in your repro, you can just say bep Dustmite on the head, and it's like, no, bep Dustmite, don't do that. But the problem that it actually causes, instead of just making everything slow, is if you kept your module named standard typecons, then it's now basically random which one of the ones you get, the one you're having and the one from Phobos. And if you're hitting the import standard version, it's pretty likely that you're going to get the one from Phobos. And the one that you copied into your source is going to get reduced to 0 lines because it does nothing. So you just rename this module to import typecons or something and change your imports everywhere. Usually, stuff that you copy out of Phobos is going to throw a bunch of syntax errors at you or semantics errors at you. Don't let that scare you. These files do run if you have them in your project. You just have to aggressively take everything that causes a semantics error and delete it. I'm not kidding. These usually unit tests, because unit tests are sort of dubiously enabled in Phobos. You just take the unit test and delete it. Or like if it's a function that's throwing an error and it's not a function that's actually used, just delete it. I mean, just throw it out. Like usually you do that 5 or 6 times and then your import works, your copied import works again. So then you've made all these changes. You've changed package to public because your module is no longer in standard. You can pretty much mass replace all package with public, all private with public. Again, this doesn't have to be upstreamed. The purpose of this file that you're creating is to be annihilated. It's to be ground down to like one atom of bug. So like, don't worry about anything. Just get it working, get it compiling, and then rerun. Right. Another thing you can do is, this starts to get a bit into inside baseball. You have a template. You have standard typecons, for instance. You have nullable. It's instantiated at one point with int and one point with float. And there's a whole bunch of methods in there that can't be removed. Like half of them can't be removed because the int side needs them, half of them can't be removed because the float side needs them. So what you do is you just take these and you just copy the entire template and you just remove the template parameter, just leave it an empty template, and you replace your instantiations with int with nullable underscore int. You replace your instantiations with float with nullable underscore float. Then you run Dustmite again. And that sort of lets it dig down into this specific template much more effectively, because now it's looking at 2 different things that are only used once. Optimally, if you're doing a reduction, you want it to have it at a point if possible, if that doesn't make the bug go away, you want to have a point where everything is used exactly once. And that's going to, once again, help Dustmite make things smaller and maybe make it even smaller than it was originally. Maybe one of them gets rid of immediately because, again, Dustmite is looking for a path through reductions. And sometimes breaking things up like that lets it find a path that it wouldn't at all be able to find otherwise. As mentioned earlier, at this point, that's the part where, honestly, you're going into stuff that is too specific to note in a talk. Like you want to make some specific magical thing where sometimes it's just reordering two functions and the bug goes away. So then maybe you can reorder in another way that makes the bug appear at a much lower level. Like at that point, you're really down to experimenting around. And this is actually where the fun starts. Because at that point, you're really starting to get into all your theories of what the bug was is going to be gone at this point. So now you can look at what the actual issue is. And you can form theories what the actual issue is going to be. And I've had issues where at the end of it, I was left with 3 empty files. I'm not even kidding. There have been wild issues in the compiler. And as a user, it's very common to think of bugs in terms of what semantic meaning we impose on the code. For instance, if I get a crash with nullable instantiated with a struct, my instinct is going to be like, okay, something with null maybe. Like, does the null state not work correctly? When from DMD's perspective, it's very probably going to be something like, well, something went wrong with this struct like 100 lines ago, and I've left a cached version of it, and now this chicken has finally come home to roost. Like, it's not going to be anything at the domain level. It's going to be something from the perspective of the compiler, and it can be very fun to try to figure out what that is. If at this point you figure out that actually 2 iterations ago I went the wrong direction, this isn't actually my bug at all, at that point you understand why we've kept so many copies of the source folder. Also, if your final reproduction includes traits compiles in any form, probably with the struct in the expression, then you can take a drink. You have joined a very populous club of speculative semantic pass bugs. These are extraordinarily common. Yeah, join the club. And of course, once again, thanks to CyberShadow for its very excellent tool, which has given me many beautiful reductions. And that's it from me.
I completely agree. Dustmite is awesome. I went through this exercise, the exact exercise, just recently, and I have one tip to add. I did the reduction, took a good week, and wrote a bug report. And then it turned out that the nightly version, the unstable version, doesn't have the bug. So check the nightly version first.
Yes, very true.
Thanks for your talk. I recognize a lot of these things from my own Dustmite work. I wonder, do you sometimes use the set-e option in bash? Because when you put it on top of a shell script, you don't have to check for errors. It will quit after one of the commands.
Yes, absolutely. The way I've written this talk, I've left it out because if you got rid of all your binaries, then set-e doesn't matter. Because what's going to happen is just the repro run is going to fail because it's not going to fail with the segfault, it's going to fail with bash telling you the file doesn't exist. When you're creating the repro script, it is very beneficial to have the standard magic bash invocation set -eu pipe fail, which basically turns on everything that should have been turned on in bash 30 years ago.
Another thing I want to say about C reduction, I've done it to find some import C bugs where I compare DMD and GCC. And on one hand, it's great that in C, everything is order dependent. So it's easy to reduce from the end. But one bad thing is that the reduced C code quickly becomes horrible with missing return statements and reading initialized variables. So I also encourage to put on as many warning as error flags as possible to try to keep the C code clean. And one final thing I want to say is that to speed up your things, try to make your invocation as short as possible. If you know it's a front-end bug, you can pass the -o flag to DMD, so it only does a syntax check. And so when the error disappears, it doesn't generate an executable for no reason.
Yeah, that's very correct. Generally speaking, you want to give Dustmite as narrow a path through to your minimization as possible. Like you don't want to have it off chasing reductions that introduce dubious errors and warnings. You want to keep it focused on the bug as tightly as possible, so turning on warnings makes a lot of sense. Another thing, while we're on the topic of speed up, it should be noted, though I forgot to note it in the talk, that Dustmite has a parallel mode. And it should also be noted that if you run Dustmite with 4 parallel build steps, then DMD can run you out of memory 4 times as fast. So be careful about that.
You think that the process of simplifying your code, you can use Dustmite to help you? That's the sort of thing a language model, when tuned on.
That is a good question, and I don't know. I would be very surprised if large language models help in this case, because I, as a human, have been very often surprised by the things that have come out.
Not to substitute for Dustmite, but to help you simplify your code so that Dustmite can run.
There's an argument for it, but however, the reason that I'm kind of skeptical is what you're going to notice is after the first run is the run that takes the most time. And usually after like the several day first run, we have things pared down enough that the actual DMD, the actual grinding through the reduction takes like an hour or two, and then maybe 10 minutes. At that point, you might as well use your human thinking time just to stay involved in the process.
So one tip, if you want to get a little bit more performance, at least in Linux, is to run it on a TMPFS so that you don't waste time on I/O. And that's not, I'm not sure if that's something you can do on Windows, but on Linux, that's an option. I should also mention that Dub has a Dustmite command. I haven't tried it, but if your project is like very heavy, uses Dub features, and you could have a look. Let us go to by Zunke, and it uses Dustmite under the hood. It just wraps it up in a nice invocation, so you don't have to extract the DMD command by hand. I also mentioned that the STD trap has been fixed in Dustmite master, and I just need to upstream it to the version that's shipped with DMD.
Beautiful, thank you. Thank you so much. While we added one additional hint, actually, if you have Dustmite with a lot of binaries in it, which is the point where I/O starts to become a real issue, what you can do is you just run it for an hour or two, and probably after an hour or two, it's gonna be rid of the binaries, and then you just cancel it and restart it. This is not usually something that's beneficial, but you have the Dustmite process itself sitting there with like a gigabyte of memory, so that it has to write out a gigabyte of debug symbol, including binaries every time. You want it to be able to cut off those parts of the tree. And the easiest way to do that is to just cancel it. And it will have created a partial reduction folder at that point. And then you just take the partial reduction folder and restart from there.
Thanks, good tip. And to add to Leith's question, so the parallel mode of Dustmite does use a predictor, and that predictor directly influences how efficient the parallel mode is. So I think there's something there.
I was just wondering if it would make sense to kind of use DMD-as-a-library to generate the AST for the code, and then try to kind of prune the AST and run semantic and maybe code generation. I know it depends on the case. If that, maybe that might speed things up.
That might be beneficial. I don't know what the state of DMD-as-a-library is to that extent. Well, you're going to always be using the Dustmite with the DMD that it's shipping with, so I don't think there's going to be incompatibilities in that sense, but I think there is maybe an advantage to Dustmite looking primarily at the syntactic level, but I'm not convinced of that. It could be beneficial, worth a try, maybe. Not sure how much.
I can try to answer that question. So the reason why Dustmite doesn't use an existing like compiler or deparsing library is that if you have a bug in your compiler, you can no longer reduce bugs in the compiler.
Oh, yeah, very true.
You explained it using source 1, source 2 as directories. I would expect you would realize you would do it as gits, branches, tags. Wouldn't you put the reduced folders, source files into Git?
Git is actually going to make a problem for you, because one of the things that Dustmite is going to tell you is that this .git folder sure has a lot of objects in it.
Okay.
And I don't like those, and I can't do anything with them. So probably the first thing actually you're going to do is just get rid of your Git folder. I don't think anything during the reduction run is going to depend on Git, or maybe I've misunderstood you.
No, I was just trying to, if when you're worried of losing your reduced source code, you would want to put it into version control, right?
If you had the version control outside, you can use that in order to like differentiate versions of the reduction. Yeah, you could do that. I'm not sure why you would. If you want to use Git tools, that is something, as long as you keep the Git folder outside of the reproduction folder, that is absolutely something you can do. Just take the reduced folder and copy it back over the original folder and then do a commit on it. If you really want to use Git tools, that's something you can do. But personally, I don't exactly see the benefit, because by the time I'm looking at the reduced bug, it's usually very far away from the original source.
Okay.
And then after that point, it's small enough that I can just see what changed.
Okay, fair answer.
I think they're done, mate.
Yeah, that's
Keep
cool.
it up.
Have a good one.